Good evening. In the last videos, we discussed very clearly about first chapter, okay, like algorithms and analysis of algorithms. What is mean by algorithm? What are the various properties of algorithms and the complexity of algorithm? How you can measure asymptotic notations, okay, and what is big O notation? What is omega notation? What is a theta notation? Theoretical concepts we covered very clearly. Next, and after that, this complexity analysis, worst case complexity, best case complexity, average case complexity, how we can calculate. Then growth of the functions also we have seen, like when an algorithm is going to take constant time, linear time, logarithmic time. These things I explained very clearly. Now in today's session, few more growth functions are there. Let me talk about those. Next one is nothing but big O of n log n function is there. Big O of n log n. So in this case, the algorithm will run in n into log n time, n into log n time. So if the execution, okay, if the execution time of an algorithm is proportional, is a proportional to the product of input size, the product of input size and logarithmic of input size. So here the algorithm is going to run n log n time, where n is nothing but the size of the input. Suppose if your input contains 10 elements, so 10 into log n, maybe it will return around 3, something like that. That means 30 times it is going to run. So in such cases, we have to go for this n log n time. Which algorithms will comes under this category? In the sense, do you know this merge sort, this quick sort, next and after that heap sort? These sorting algorithms will come with this time, because in these sorting techniques there will be two approaches. One approach is nothing but for dividing the list. Second approach is nothing but to perform merge operation. So for
What is
this,
P, sir?
Sir,
What is P, sir?
what is,
I divided by P. P, sir. P,
sir,
P,
please
P.
listen the class, sir. Input size. So in the merge sort, we are going to divide the list first. We are going to divide a big list into small parts. Then after that, we are going to combine by comparing each and every element with the remaining elements. So this is the concept which we are going to follow in merge sort, as well as heap sort, as well as quick sort. In this technique, this algorithm is divided into two phases. In the first phase, we are going to divide the entire list. So it will take n time. In this case, we are going to merge. It will take log n time. So by combining these, the complexity of these algorithms we can measure by using n log n. So an algorithm can use this kind of complexity also, depending on the situation. That we will see in the later classes, but theoretical definition I am providing. Next. So next one is quadratic time. Okay, quadratic time. Yes, an algorithm can have quadratic time also. Big O of n square. Just for our understanding purpose, I am telling n power 2. So an algorithm is said to run in quadratic time. Quadratic time of an algorithm is proportional to square of the input size. So there are some algorithms are there which will work with this. For example, bubble sort algorithm, selection sort algorithm, insertion sort algorithm. All these algorithms are going to work with this time only. because in the case of bubble sort, we have to use two loops. One loop is used to generate the number, I mean to drop the number, and the second loop we have to compare that number with remaining all the elements. That's why so compulsory two loops we have to use. If anywhere we are using two loops means its a time complexity is nothing but big O of n square depending on the input. Suppose if input size is 10, that means 100 times it is going to run. That I will show you how it is going to work. So I think you people got clear clarity about big O of n log n measurement, how you can use, and big O of n square, how we can able to use. So previous to this, we discussed about log n time complexity, big O of n time complexity, big O of 1. I think you know big O of 1 will take less time when compared with next level complexity big O of log n. Next level complexity is big O of n. Next level complexity is big O of n log n. So next one is n square. I think if you substitute the value of n, automatically you are going to get these values. So how to measure this complexity by using this big O of n log n and a big O of n square? Is these two theoretical approaches are clear for you people? Please confirm.
Yes, sir.
No,
Right.
sir, but we have to by heart it that the bubble shot, the die complexity of bubble shot is going to be quadratic.
Yes,
And
yes,
selection shot is going to
yes. But how it is going to work, I will explain while explaining the bubble sort. It is very simple only, sir, not that much hard.
okay.
So depending on the
Okay.
algorithm, how many loops are there? So based on that, we will judge. It is a matter of 1 or 2 minutes. While explaining the
Mhm.
algorithm itself, I will give. But I am telling
And
we
sir,
can represent a complexity of an algorithm with big O of n square. Which algorithms will comes under that category? I am explaining at top level.
okay. So
Okay.
you mean to say, if all the algorithm in this universe falls, either is 5 of them
Hmm.
in the terms of time complexity.
Yeah, all these algorithms we are going to measure with these 5. Still, we have 2 more complexities are there, 2 more measurements are there.
Okay, so let's
It
say
may
seven
vary, sir.
measurements are.
Yeah. Suppose
So
here
all
n
the
square, n square is there. Sometimes you may get n cube also. Sometimes you may get n power also. Here n log n, sometimes the 2n log n. Like that, it may vary, but almost it is the same with this.
okay, and sir, what about the fourth one, n log n, right? What is the
N
base
log
of
n.
that log n?
Sir,
What is
you
the base
can
of
take
this one?
either 2 or 10, sir, because these algorithms we are going to measure by taking some theoretical formulas. So by default, in our cases, we are going to take the base as a 2.
Base 2. Okay.
Yeah, base is 2. While writing the statements, while writing the recurrence relation, we are going to take that 2 power, something like that it is going to take. Once if you apply logarithm, then we will take base 2. So that easily we can calculate.
Sir, I have a question.
Hmm.
Suppose now before 2 to 3 lectures, and we have conducted some problems. So, how we are supposed to know that for us, or if we are solving one prime number problem, so how we can come to know that which big of notation, or which how the time efficient, which algorithm would be suitable for this particular problem? How we are supposed to
Sir,
know?
we are at theoretical level, sir. I will explain this by taking some problems. Then
Okay.
I will explain how you can able to measure the time complexity for that. Then
And
you will get clarity.
the basic purpose behind that, how this is for, we have to make we have to apply for to make our program a code efficient, right?
Yes.
So
See here, suppose if I am developing any algorithm, so one algorithm is taking big O of log n time, other algorithm is taking big O of n log n time. Can you please tell me which is efficient, big O of log n or big O of n log n?
big of
Big O of
Big
n.
O of login.
Yes, that's all. With this algorithm is going to give best performance with
Yes.
respect to time and space. That's all.
And one
Of
thing, sir,
course,
regarding this, I have not received the video related from
sir,
Monday.
videos, running notes, all these things we will discuss at the end of the session,
Okay,
sir.
okay, sir. Sorry for
Yeah.
interruption.
Yeah, right.
So what is login, sir?
Sir, log n is a logarithmic function, sir.
Okay.
In mathematics, we have log values are there, right?
Yes, sir.
So that is representing here.
Okay.
Log n means logarithmic value.
Okay, sir.
Hello.
Right. Yes.
Sir, can an algorithm have multiple time complexity also?
An algorithm can have
Multiple time complexity?
how, sir? An algorithm is going to give only one solution, right? For a
Yes.
problem, you can develop multiple algorithms. Every algorithm will have a different complexities. Among those, you have to choose the best one. So single algorithm can't have multiple complexities. Then there is no need for studying this complexity theory, right? If such a type of scenario is there. Got it?
Interviewer can ask order of algorithm. Means
I'm not getting.
which one can take minimum time complexity?
So that's we are going to measure by using these represent. Just now I have given one example, right? Suppose if an algorithm is taking big O of log n and other approach I developed, which is taking big O of n log n. So in these two cases, which algorithm is going to run efficiently? Big O of log n, because so you can able to see if you substitute the value of n, suppose if n value is a 10, so log 10 is going to give very less results when compared with n into log n. Suppose consider log n is going to give 3, n log n 10 into 3, 30. So which is best? This one is the best, right? So that's one
Yes.
we have to select. Okay.
We have to remember order also. So which one will take?
No
minimum
need to remember. Just I am telling what are the units to represent. So I explained a total 5 units, right? So when you are writing the algorithm, we will analyze whether it is taking 2 loops or 3 loops, how it is going to work. For every algorithm, I will explain the complexity. While explaining that complexity, I will measure by using these words. That's what in the beginning I am telling. These are the representations that we have. Got it?
But we can define some order also.
We can define.
Increasing order, which one will take?
Yeah. We can define. That depends on the algorithm only, right? We can't give
Yes.
directly here. Suppose if your algorithm is taking constant time, this is the representation. You are telling it is keep on increasing means it will be n square, something like that. That depends. Okay.
Okay.
Yeah. Aman Agarwal, what is that? I'm not getting. Can you please confirm? Aman Agarwal, what is your query?
Hello.
Yes.
Yeah, actually, I am saying just can we discuss portions in the queries in the last? Is that possible?
No. Questions related to the subject you can ask now itself, but remaining activities we can do at the end. So because once if the small topic got completed, let us discuss these questions here itself. Okay.
So that
Yes.
then and there only our doubt will.
Yeah. Because once if I skip this topic, see in our next upcoming classes, once if this topic is completed, so we are not going to touch this topic anywhere. So that much clarity you need to get in the beginning itself. That's why let us clarify all the doubts on the spot itself. So these doubts you have to ask related to the content. So don't ask regarding running notes or videos or WhatsApp group. All these things we can discuss at the end, please.
Sir, one question is there. Input size is about like a number of element in a list.
You can say, for example, if you are taking an array,
Yes.
based on that array, you are performing some operations. Suppose consider you are doing searching operation. Okay. So if your input is having 10 elements, how many comparisons you have to do? 10 comparisons. If your array size is 100, you have to do 100 comparisons, which will take which time complexity? Log n time n complexity, big O of n. Suppose if I have 100 elements are there, so I want to search for an element by using binary search, then it will take big O of log n, because this is the beautiful searching algorithm which will divide the entire list into two parts and it will eliminate half of the part every time. Okay.
Sir, one more doubt. Sir, in case of binary tree, like how will we manage input size?
Sir, binary?
Sir, binary tree.
Hmm.
If you talk about the binary tree in which like we will search all the nodes, then move left to right, like
Yeah, we
that-
are going.
in that scenario, like how we will like manage how we will input size, because in that we don't know the input size on the basis of
You are
root.
talking about binary search tree.
Yes, sir.
Sir, we will discuss about that later, sir. Is it required to discuss now?
Okay, pardon me, sir. Carry
Yeah,
on.
because just we are, I'm giving the notations. That's all, sir. Please concentrate on these notations. So these notations are applicable for which algorithms means while explaining the algorithm, I will give clarity. So here itself, I can't give binary tree is going to take a binary search tree when you are inserting operation, how it is going to take like that. We can't give here itself, right? So we will discuss that in the algorithms. Okay.
Sir, these are all explained the practical, sir.
Yes. For
Why
every
student-
algorithm.
Why students are again repeat the questions and
Yeah, I
theory
don't know what
part.
is happening. See, this is the theory part, sir. Suppose if I want to represent the distance, kilometers, meters, so centimeters, like this we have, right? That I am explaining. So if you are asking, sir, how much distance is there from
got it,
this
got
place to this place means, once if you travel, we will came to know. So now these are the growth of the functions. If I want to measure complexity of any algorithm, compulsory we have to take any one of these. That's what I am telling. Okay.
Yes, I got it now. Actually, this you are just whatever the basic things are required to understand the DSA, that you are
Hmm.
completing. That you are
Yes,
making us understand.
yes.
Yeah. Got it now. Thank you.
Right. Right. The next one, I'm going for exponential time. So how you can measure the exponential time of an algorithm? By taking big O of 2 power n, 2 power n. So it can be anything, 2 cube or 2 power 4 or 3 cube or 4 cube, anything. So 2 power, something like this. If you are getting here, it is n square, n cube, n power 4 like that. But here n will come at the top. 2 power 4, 2 power 5, like that if you are getting. So such type of things are called as exponential time. So in this case, so in these algorithms, all possible subsets of elements of input size, input data are generated. In this case, all the possible subsets are going to generate. Best example, we are going to see power set applications and then subset applications. In these areas, we are going to use this exponential time. Subset means what? Suppose if I have an array with 5 elements, what are the possible subsets are there for this? If I want to find out such a type of algorithm, then it will take exponential time. And the last measurement, so factorial time is also there. So how you can represent this factorial time means, so big O of n factorial, like that we can take. So here all possible permutations, wherever permutations are there, so there we are going to use this factorial time. All possible permutations of all the elements of input data are generated, means in such a cases we can use this factorial. Best example, finding permutations of a string, of an array, like that we can take. So these are nothing but some examples for these notations. Some of the examples for these notations like this, we have so many notations are there. These are the commonly used notations what we have. So in our upcoming classes when we are talking about any algorithm. Okay, so that algorithm will have a complexity. So we are going to measure that complexity by using any one of these 7 or 8 functions. So this is nothing but the growth of the functions to measure complexity of any algorithm. I think you people got a clear clarity about this. So you people are going in deeper into this. Don't go, just try to understand the theoretical concept. Once if I go to the programming approach, then you people are going to get clarity on this. Can you please confirm everyone? Is this clear up to this?
Yes, sir.
Right. Now we are going to see the complexity calculations for sample programs we will discuss. Example number 1. Sir, since we don't have any loops, while loop, for loop, such type of terminology is not there. We have only one loop is there in our Python, which is nothing but a while. So for loop is not a for loop, it is a for each loop. That's why I want to measure the time complexity of a loop first of all. How to measure time complexity of a loop, I am going to explain here. Okay, so I am taking test.py program. Listen carefully. I am going to define a function which will take a number n. This function is going to initialize count is equal to 0, so that I will count how many times my loop is going to run, and I value is equal to initially 0 until your I value is less than n. Until your I value is less than n. Okay, so until my I value is less than n, I am going to do one activity. What is that activity? Count is equal to count plus I. Count is equal to count plus 1. Then updating the value of I. I is equal to I plus 1. Like this I am doing. Right. So like this I am repeating, and finally I want to return the value of C. Sir, how this function is going to work? Observe carefully. Suppose consider I am giving the value of n is equal to 5. What is the initial value of count? 0. What is the initial value of I? 0. Is 0 is less than 5? Yes. Then count value we are incrementing by 1 unit. I value also we are incrementing by 1 unit. Count will become 1, I will become 1. So then next time, since it is a loop, one more time it will run. Now it is checking I value 1 is less than 5. Yes, condition true. So count also will be incremented by 1 unit. I also incremented by 1 unit. Now your I value is 2. Is it less than 5? Yes. Then count also will be incremented by 1 unit. I is also incremented. Next time I value is 3. 3 is less than 5. Condition satisfied. Both will be incremented by 1 unit. Now I is 4. 4 less than 5. Condition satisfied. So it will be incremented by 1 unit. It will be incremented by 1 unit. So 5 less than 5. Condition is not satisfied. Now I am going to return C value. What is the C value? 5. That means if the input size is 5, how many times my loop is running? 5 times. Can I say this particular complexity as a big O of n? Yes, because this loop is going to take a complexity big O of n. So it depends on the value of n. If you are giving n is equal to 5, exactly 5 times it is going to run. Suppose if you provide n is equal to 100, my loop is going to run how many times? 100 times. So for n is equal to 1000 times. So that is nothing but complexity is, it is nothing but a linear fashion, right? Big O of n is nothing but the complexity of this particular loop. So let us document that. So I am using print of. Suppose if n is equal to 100, assume n is equal to 100. So the number of instructions, the number of instructions is directly I am writing big O of n, and its value is nothing but what, sir? If you call the function by passing 100, definitely it is going to run how many times? Compulsory it is going to run 100 times, sir. Compulsory it is going to run 100 times. Let us cross check. Just I am going to take 8 p.m. So py space test.py I am taking. you can see how many times it is running, 100 times. So the time complexity of this algorithm is nothing but big O of n. I request everyone to please confirm, is this a first example? Is it clear for you people?
Yes, sir. Got it. It's very clear.
Sir, I have a doubt.
Yes, please, sir.
Sir, why you have, taken two variable? You can do it with one variable also instead of C, either with C or I.
Yeah, yes, we can do with one variable, but in future, I'm going to change the value of I rapidly. So I want to maintain how many times this loop is going to run. For that, I assigned a separate variable for counting purpose, because in our upcoming classes, I mean upcoming programs, I may change the value of I double or by 2, like that I can change. But a count value, only one value we have to increment, right? That's why I assigned different variables. Okay. Got it?
And
So,
sir,
yes.
you told about while loop. You told about some for loop. I didn't get that. It's for loop. We cannot.
Yeah, we see. We don't have for loop in Python, sir. We
For
have
each
for each
loop,
loop.
for each
Yeah,
loop,
for
yeah.
each loop is there. We can't use such type of loops for our running purpose, right? Because so that will work only for sequences. Like we can apply for a string or for a
List,
list.
couple.
We can apply for a tuple or range, like that we can use. So you can't run for your own. Okay, I want to repeat for 100 times means we don't have any option by using for each. So that's why the majority looping statement in our Python is nothing but a while loop only. Got it?
Okay, sir.
Yeah.
Sir, as you told that for loop is not available in Python, is it so?
For loop is not there, sir. For each loop is there. In other programming languages, we have for loop and we have while loop. But here, the behavior of for each loop is different. It is not like for loop. Okay.
Means sir, for any sequence we need to iterate that. Mostly the preferable is we are using for loop, right?
Yeah, then we can use it. Here sequence is not there, right?
Yeah, right.
So that's why I have taken while loop. If anywhere sequence is there in your input, then you can use, no problem.
For maximum sequence data structure, maximum possibly we can go for loop, means
loop,
dictionary,
yes.
list, couple. And for set we are not able to use, right? Because set doesn't perform order.
Yeah, we can use a set. What is your question? Last question. Can you repeat?
Means for loop we cannot use in set because set doesn't follow order, right?
No.
It doesn't have any sequence.
No. Set is a sequence, sir. We can use for each loop for that. No problem. See, for each loop is applicable only for sequences. It is not based on index. Some data structure may
right.
have index. Some
got it.
data structure may not. Ram is asking, sir, what is the difference between for loop and for each loop? Don't worry. I'm going to take one fundamental section on Saturday. There you will get the clarity. I will cover the Python fundamentals. There you will see. Okay. Right. Sir, I'm moving for the next example. Yeah.
No, sir. You just told now means basic Python first 20 program will cover, right?
Yeah, that's
You
what
just
I'm telling.
started?
I will cover Python, sir. Don't worry. Basics of Python,
No.
I will cover.
Okay.
Right. So this is nothing but the first example what we have here. By using loop, how we can able to calculate these things. Second example, I want to apply nested loops. I want to apply nested loops. In this one scenario is there. Let us see how it is going to work. So consider here, I am taking a function, count is equal to as usual 0, I is equal to 0 until your I value is less than n. So in this, again I am taking one more loop, j is equal to 0, while j value is less than n. So then I am incrementing count is equal to count plus 1 and j is equal to j plus 1. Like this I am taking. So in this case, I want to see what is the complexity of this algorithm, sir. Very simple. Observe carefully. Suppose if I am giving the value of n is equal to 5, sir, what will happen? Count is equal to initially 0. Otherwise, for simplicity purpose, I am giving the value of n is equal to 3. Count is equal to initially 0. So your I value will become 0. Then is I value is less than n? Yes, condition satisfied. Then j will become 0. Sir, is this j is less than 3? Yes. Then count will become count plus 1. Your count is 1. J is equal to j plus 1. J will become 1. Is 1 is less than 3? Condition satisfied. Count will become 2. So then j value is incremented 2 less than 3. Condition satisfied. So it is going to execute 3 times. So next 3 less than 3, condition not satisfied. That means for every I value, how many times j is executing? 3 times. That's why 3. Next, when I is equal to 1, what will happen? 1 less than 3. Again, definitely it is going to run for 3 times. 3 plus 3 is 6. So when I is equal to 2, 2 less than 3. So how many times this j loop is going to execute? 3 times. Sir, can I take 9? Yes. When I is equal to 3, 3 less than 3, condition not satisfied. That means for every iteration of I, j values are going to execute how many times? N times. If n is equal to 3, when I is equal to 0, 3 times. When I is equal to 1, 3 times. When I is equal to 2, 3 times. Like this, it is going to work. Sir, the total time, total number of instructions here is nothing but 9. When if your n is equal to 3, it is running 9 times. If your n is equal to 2, then what will happen? So 2 plus 2, 4 times, right? It is going to run 4 times. If your n is equal to 1, it is going to run 1 time. Sir, if your n is equal to 4, definitely. So 4, 4, 4, 4. Total 16 times. Sir, can I take, if n is the given input, it is going to work n square time? Yes, then it will become big O of n square. This is nothing but the complexity of this algorithm, big O of n square. That means for this, what output I am expecting? 100 is the given input, means 100 into 100 times it is going to work, which is nothing but 10,000 times it is going to work, sir. Okay, sir, can you please confirm? First, I will execute this code so that you people will get clarity. Sir, is it working 10,000 times or not? Yes. I think how to calculate complexity by using these algorithms, these measurements, is clear for you people. I think so. Can you please confirm any doubts up to this? Please respond.
Can you show the line number 1 and 2 as well?
1 and
1 and 2.
1 and 2. Where, sir? Already it is there in the screen.
I
No.
mean, function definition, sir. The person is asking.
Yeah, it is already there, right? Are you able to see my screen? So I request everyone to please respond clear up to this.
Yes,
Hello.
Yes,
Yeah,
sir.
yes, sir.
Yes, sir. Please.
Yes,
Hello,
sir.
sir.
I have a question.
Hmm.
Sir, as we start the function, first it will check the while loop where in the initial I is 0.
Hmm.
Then he will check j is 0. Then j will compare to like 0 is compared to n. Then further execute. Okay. So
Hmm.
like up to like 3 times it will work inside nested loop.
Hmm.
Am I right, sir?
Yeah, yes, sir. For I
And-
is equal to 0, nested loop will run again 3 times because
Okay.
j value is depending on the value of n, right?
Yes, sir.
So,
Then after that it will come to I at line number 9 where I will become 1. Then it will again.
So whatever I have taken in this box,
Yes, sir.
so this is related to the inner while loop. Once if this while loop condition fail, then only this line will continue. That means for I is equal to 0, so your j values will become 0 and your j value will become 1 and your j value will become 2. When j become 3, this condition is not satisfied. It is coming out from the loop. Again,
Yes,
I value will be incremented by 1 unit. Again,
Yes,
for I is equal to 1, j value will start from 0 because you have given here from j is equal to 0. So like again, it will run 3 times.
Okay,
So,
okay, got it,
got
sir.
it.
Like, sir, what is doubt is mine is like as you said, na, like J value goes up to 16. Like up to 16. So I was confused. Like, you resolve the problem when
No. I am
from
not
line
talking
five,
about J.
from
I
five
am not. No.
from
I am not
line
talking
number
about
5.
J.
Every time it will become 0, then it will
Sir,
execute the equation.
Listen my words, Deepak.
Yes, sir.
I am not talking about J. I am talking about C, count value. Count value is keep on increasing. Okay.
Yes,
So
sir.
count value, how many times this loop is going to execute, that I am measuring by using this counter value. So where I have kept this counter inside inner loop, right?
Yes,
So
sir.
how many times this particular instruction is going to execute? In this case, it will execute. 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 In all these cases, it will execute, right?
Yes.
So what is the final value of counter? 0 here, 1, 2, 3, 4, 5, 6, 7, 8, 9. If input is 3, so it is going to execute 9 times.
Yes, I got it.
If your input is 4 means what? One more loop will come here.
Yes.
So one more loop will come here. One more time it will come here. One more I value will come here. Got it? Here
Yes, sir.
4 times, here 4, here 4, here 4. Total 16. Got
Yes.
it?
Yes, thank you, sir.
Right. Sir, I request everyone to please confirm. Clear up to this?
Hello, sir. I have one doubt.
Yes.
Sir, in your growth of function, you mentioned binary search as having log n complexity. But suppose our list is not in the sorting order, then in that case, first we have to sort that list and then we are searching. So
yes.
in that case, it is still taking a log n time or any other?
It will take log n time. I am talking about binary search algorithm only. But if you want to apply binary search algorithm, the first property is nothing but list must be in sorted order. Then only you can apply binary search. Otherwise, you can't apply binary search. That we will discuss in the binary search, sir. As of now, it is not required. Okay.
Okay, sir. Thank you.
Sir, in short, could you explain in short in theory, big O n square? Now you explained example. Just explain in theory. Just overall.
Sir, nothing, sir. Sir, it is depending on the value of n. Here itself, clearly it is telling if n is equal to 1, it is going to run 1 time. If n is equal to 2, it is going to run 4 times because 2 square. If n is equal to 3, 3 square. N is equal to 4, 4 square. N is equal to 5, 5 square. If n is equal to n, n square times it is going to run. That's what the complexity is big of n square.
Okay.
Sir, don't go in detail, sir. Just a top level, try to understand. Because here itself, if you are feeling like this, then learning the algorithms will become very difficult for us. So please don't take everything into your mind. Just at a top level, try to understand. And I request everyone, please remind you must have idea about Python when you are learning this. Because these internal implementations, if I want to explain one by one, so definitely it is going to take longer time. So I think these first 2 examples are clear for you people, right? Please give confirmation. Clear up to this?
Yes, sir. It's very clear.
Right.
After solution, we can decide now which algorithm is best, right?
Now we are not going to decide which algorithm is best. Just
No,
we are
I'm just a general question, sir. Suppose after solution we decide now for which algorithm we need to.
Yes. In this algorithm, have you seen how much time it is taking?
10,000.
Yeah, same algorithm I will write in the last example, which is going to reduce this particular comparison, but same logic only. Same concept I am going to use, but it will reduce the time. So this one is best or that one is best means the algorithm which I am going to explain in future, it will be the best. Okay.
Thank you.
Sir, if you don't create dependency in between both loops,
if you create a dependency, definitely it is going to impact the complexity, right?
If you don't create a dependency, then what will be the time complexity for that?
Here, is there any dependency? No, right? So that's why it is
Dependency is there in between J and N.
No, who told? J loop is executing separately. Is there any J value, I value in these three?
Inner loop is depend on outer loop.
Sir, inner loop, sir, this is inner loop. Inner loop is not depending on outer loop. We have taken this loop inside another loop. How many times this loop is executing, those many times this loop will execute. It is not depending. If it is depending, I can take the value of I here. That means what is the value of I it is giving, based on that J loop is running. Then it is called as a dependency. Now it is not a dependency. Is there any dependency value for I? Suppose if your n is equal to 3, how many times this J loop is going to run, sir? Can you please tell me? If n is equal to 3, how many times J loop is going to run?
9
3 times.
times.
No, 3 times, right? For one
3
value I
times.
am taking. See, for example, if you take the value of I is equal to 0, so J loop is executing how many times? 3 times. When I is equal to 1, J loop is executing how many times? 3 times. When I is equal to 2, J loop is executing how many times? 3 times. Is there any dependency, sir?
No.
No.
No,
If
no.
dependency is there, if I is equal to 0, you have to execute only one time. If I is equal to 1, J loop has to execute 2 times. If I is equal to 2, J loop has to execute 3 times. Now dependency is there. The value of J is depending on I value. The execution of J is depending on I value. Like that we have. Got it?
In the dependency case, it will take.
Definitely time complexity is going to change. That we will discuss, sir.
Yes.
Don't worry. In the next
Okay.
examples, we will talk about that. Okay.
Thank you.
Right, sir. So now, so this is nothing but what we have about this particular loop, how we can able to execute. Now, sir, one more question for you people. You have to tell answer for this. Example number 3. Sir, nested loops, I am taking part 2. What is this part 2 is? Sir, I am going to take, okay, here I am going to take one more extra loop. Sir, I is there, I loop is working fine, J loop is there, it is also working fine. In addition to that, I will take a K loop. So while your K value is less than N and C is equal to C plus 1 and K is equal to, as usual, K plus 1. So in this case, you can able to see here. Suppose if the value of I is equal to 0, then your J value will become 0, your J value will become 1, your J value will become 2. Assume I am giving the value of N is equal to 3. For every J, again, sir, we have K values, right? Like this we have. Again, K values are there like this. Okay. Again, K values are like this. Sir, can you please confirm this one is going to repeat for I is equal to 1. Same thing is going to repeat for I is equal to 2. That means when I is equal to 0, how many times C value is, how many times this loop is executing? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times. When I is equal to 1, 9 times. When I is equal to 2, 9 times. Can I take, if N is equal to 3, 9 plus 9 plus 9, almost it is 27. Sir, can I write it as 3 cube? Yes. When N is equal to 4, I think 64 we are going to get 4 power 4. Okay. So for example, if N value I am giving, sir, can I say it is going to run N cube times I think here also 4 cube, something like that, because 3 loops I am using, right? Like this. Sir, the time complexity of this algorithm is nothing but big O of N cube. Why N cube? Because 3 loops are there. So now if we are taking N cube, so how many times it is going to execute? 100 into 100 into 100. Additionally, 2 extra zeros we are going to get. Okay. So I think how these loops are working internally, you people got clarity now. Can you please confirm, everyone clear up to this?
Sir, yes, sir, I have small doubt, but sir, inside the while loop, number of while loops can be used or only 2 or 3?
You can use any number of while loops, sir. What is this question? A loop inside a loop is possible, right? You can write any number of loops.
I stored only one value in 12th line. I store only one value or more than one value?
Sir, you are asking irrelevant doubts, sir. See here, I is equal to, I started from 0, I value less than n, I plus plus. I value start from 0, 0 less than n, I is equal to I plus 1. One by one it is executing. Why we are going to change this value?
Oh, sorry, sir. I am not.
Yeah, I request everyone to please confirm. Clear up to this?
Yes, sir.
Yes.
Right.
Yes, sir. Sir, you are using the same function again and again, overwriting on the same function. So are you going to share this code also, or at the end?
Yeah, sir, I will share, sir. Here you can see, like this you are going to get example,
Okay,
title of this example, and the program will be there. Even I copy pasted output also.
Okay. Thanks, sir. Because it will be helpful for revision actually. So that is what I have.
Yeah, I will send, sir. I will send. Whenever I'm doing overriding, compulsory backup I am going to copy paste. Don't worry.
Okay. Thank you so much, sir.
Right, sir.
As a loop increases, as we are giving 3 nested loop we are using, so time complexity has been increasing, right?
Definitely, sir. Now you can guess if a problem is having more number of loops, means definitely time complexity is keep on increasing, right? We have to concentrate how we can able to reduce the loops. That is our main agenda. In the previous example also I have told, see, bubble sort, selection sort, insertion sort are taking n square. That means if you have 100 elements are there, how many comparisons it requires? 10,000 comparisons. That will be reduced in merge sort and quick sort. Got it? Log 100, almost it will be returned 7. So n value is 7. So 7 into log, n value is 100. 100 into 7 means 700 comparisons. 10,000 is big or 700 is big? 700. That's why merge sort, quick sort are the best algorithms when compared with sorting techniques. Among all these sorting techniques, these are the best.
So it is exactly opposite of exponential or quadratic logarithmic, right?
Yes.
We are over here, the time is increasing, and to depreciate that, we can use logarithm, right?
Yes. But how it is going to work also, I will explain by using this while loop only. Don't worry.
Okay, sir. Got it.
Shantanu, correct. Your answer is correct. Right, sir. That's all about today's session. So remaining things we will continue tomorrow. Okay. So maximum by today night, you are going to receive the running notes in your respective folders with the diagrams. Don't worry. Everyone is going to receive that running notes. I'm going to delete the old running notes and I'm giving access for each and every person newly. Okay. By today night, you will get it. Okay. Right, sir. Thank you. See you tomorrow.
Thank you. Thank you, sir.
Yes.
Sir, the question was regarding this that on Monday and Tuesday that 2 videos I have not received yet, and apart from that, the link which has been shared by admin team, it has been constantly changing. So
no. When you have joined, sir?
I have joined on 28 or 29 only. I have paid the money.
This is the permanent link, sir. This is the permanent link. The link which you used today to join the class, this is the permanent link.
Okay.
So we have changed only 2 links. One is a demo and this is the regular link. Okay.
Hello.
Yes.
Sir.
Yes.
I think as you are explaining, I think means to understand DSA, it's a very big coding is required. I think, right?
No, sir.
Not like that.
See that in the future classes, not required.
Okay.
But very beginning you may feel difficulty. That's all. But nothing is there. Once if you understand, it will become very easy. Okay.
Okay, sir. Once you share this yesterday and today's class, now, then we will revise all these things. Then we will feel little easy.
Sir, have you created a WhatsApp group?
No, sir. No, sir. Not yet created. Tomorrow or day after tomorrow, we will see that. Okay.
Okay, okay, sir. Fine.
Sir, after complete the one copy of the actually one chapter, any conducted mock tests?
No, no, sir. No, sir. No.
Okay.
Yeah, right. So tomorrow we will discuss all these things, sir. I have a continuity class is there. Tomorrow we will meet for at 8 o'clock. I request everyone to please join exactly at 8 o'clock. Okay.
Okay, thank you, sir. Good night.
Right. Thank you. Good night.